Hey guys, this time I'd like to take you to a trip through our solar system to get to know our cosmic neighborhood better. So satellites like the Interstellar Boundary Explorer by NASA help us make a map of the boundary of the solar system and interstellar space, which is how we know that our solar system is located along the inner rim of an interstellar cavity known as a local bubble, some 26,000 light years from the center and halfway along the Orion spiral arm of the Milky Way galaxy. Even though we are speeding along the center of the galaxy at an amazing speed of 200 kilometers per second, we have completed only about 1,000th of a revolution around the center since the emergence of humans. This should give you a sense of how massive our Milky Way galaxy really is. So the number of planets are just matters of convention, and astronomers actually judge missions on the basis of scientific merit and not whether it's going to a planet or not. We have found a definite structure to our solar system which is different from many other systems that we have been studied. And the first group of planets are called the terrestrial planets, the second group are the Jovian or gaseous planets, and the third kind of bodies which are in the outer reaches of the solar system are called the Kuiper belt objects, beyond which lies the Oort cloud and then the helioshock. So the terrestrial planets, which are the closest planets to the sun, out of the bodies in the solar system, include Mercury, Venus, Earth, and Mars, and they are characterized by their solid rocky interiors, thin atmospheres, small radius, and low mass. Named after the celestial messenger to the Roman gods, Mercury is the closest planet to the sun, which explains why the temperatures on it range from 450 degrees Celsius all the way to minus 170 degrees Celsius on the side of the sun, of the side of Mercury which is not facing the sun. Mercury's highly eccentric orbit actually helped prove the general theory of relativity, and it gives rise to several interesting phenomena on the surface of Mercury, such as the sun sometimes rises halfway and then reverses direction to set in the same place it came from. And a single day on Mercury lasts almost 2 Mercurian years. The most successful missions to Mercury have been the Mariner and Messenger missions, which have provided us with a lot of surprising data, such as the presence of a magnetic field which is similar to Earth's and which is almost as strong. This is possibly due to Mercury's large core, and also water, ice, and organics have been found on Mercury, which is pretty surprising too. And also there is the presence of an atmosphere which thins and thickens as Mercury approaches and recedes from the Sun. So Venus was long thought to be a tropical paradise that could have been a potential second home for us, but such illusions were shattered with the advent of radio mapping in the 1960s, which revealed its hostile environment. The surface temperature is hot enough to melt lead at 462 degrees Celsius, and the air pressure is 90 times that of Earth. This is all due to a runaway greenhouse effect with clouds of sulfur and carbon dioxide trapping whatever little heat manages to reach the surface of Venus through its highly reflective clouds, which incidentally also rain acid rain on the surface of Venus. A peculiar feature of the rotational feature of Venus is retrograde rotation, due to which the Sun rises in the west on Venus and sets in the east. Notable missions to Venus include the Venera by USSR, Mariner and Magellan by NASA, and the Venus Express by ESA. They provided evidence for past oceans of water on Venus, which evaporated a billion years later after the formation on Venus because of lack of magnetic field and erosion by the solar wind. There's also evidence for lightning storms and an ozone layer on Venus. So Earth is the only planet we can call home for now, and it was formed 4.5 billion years ago, with life evolving a billion years later. Water and ice, which are building blocks of the life we know of, are theorized to have been delivered by asteroids and comets, and the greenhouse effect initially kept oceans from freezing. So the Earth was a very different place from what it is now. And lightning storms in fact helped synthesize the complex proteins which are the building blocks of life. Another feature which protected emerging life on Earth was the strong magnetic field of the Earth, which serves as a protective shield from the solar wind and also helps some animals to give them a sense of direction. So Earth is the only planet with plate tectonics, without which carbon wouldn't have been recycled and we would have ended up with a greenhouse effect like Venus. Incidentally, there's enough gold in the Earth's core to form a foot-high coat on the surface of the entire Earth too. It's a mistake to think that we know Earth well enough, as we have identified merely 14% of the Earth's species, among which there are some which even survive using the radioactivity of uranium. The most prevalent theory for the formation of the moon is that a Mars-sized object hit the Earth at just the right angle to eject material out of the Earth to form the moon, and we should be thankful for that, for otherwise the Earth would have been a very different place. The moon is essential for keeping the axial tilt of the Earth constant, to provide us with seasons which last mere months as opposed to decades of summer and winter we would have had otherwise. Days would have been only 6 hours long with faster winds and stronger storms, which would have surely made life much more difficult. It also helps regulate the tides for us so that our coastal ecosystem can develop. Apart from all this, probably humanity wouldn't even have progressed so fast, as without a prominent target in the night sky, the space race would have been kind of pointless. For these reasons, moon has been a popular destination for us humans, and we know it quite well as a consequence. There are mirrors on the moon placed by astronauts to measure the distance to the moon accurately using lasers, and we know that the moon is actually moving away from us by 1.4 inches per year. They have even installed high-speed internet on the moon. So future missions to the moon include Chandrayaan-2 and some private teams competing for the Google's Lunar X Prize to run a rover on the moon, with Team Indus from India making substantial progress. There are also plans to develop a complete lunar network and connected nodes so that the moon can serve as a future base for humanity. The Earth's moon, like most bodies in gravitational relationships, is tidally locked to the Earth. This means that the moon makes exactly one rotation on its axis for every revolution around the Earth. A consequence of this is that until we sent satellites to the dark side of the moon, no one knew anything about it. Little green men from Mars have been a popular feature of a lot of science fiction, but in fact, Mars seems to have the bare minimum conditions for life. Meteorites from Mars have actually fallen on the Earth, and there was controversy with some scientific groups claiming the existence of Martian bacteria on them, but they were later on discovered to be just some kind of scientific anomaly. The surface gravity of Mars is just 37% of that of the Earth, which is why structures like the Olympus Mons, the tallest volcano known on a planet in the solar system, is possible on Mars. It's 25 kilometers high and has a diameter equal to almost a large Indian state at 600 kilometers. So this is a beautiful color photograph provided by India's Mangalyaan mission, which we are very proud of because its budget was lesser than that of a typical Hollywood film, which is a great achievement for India indeed. So the current missions to Mars include the Mars Odyssey, the Mars Express, the Opportunity rover, the Mars Reconnaissance mission, Curiosity rover, the Mars Orbiter mission, and Maven. So proposed missions also include stuff like Mangalyaan 2, advanced landers to see whether human settlement on Mars is feasible, and some future settlement missions such as Mars 1, but they face a lot of challenges like high costs, the psychological factors of living in closed spaces over long periods of time, and also the health risks due to the different types of radiation one might be exposed to on Mars. Phobos and Deimos are the two tiny companions of Mars. Their origin is still under debate with similarities with asteroids, but they also have nearly circular objects around Mars, ruling out capture from the asteroid main belt. So it's quite puzzling actually. Phobos orbits Mars about 3 times a day and is said to be spiraling inwards towards Mars, and Deimos is the smaller of the two and orbits at a much larger distance. So missions have also been proposed which involve launching projectiles at the surfaces of these two moons and collecting debris in a slow flyby. So these are the tasks we have for you this time, and we would like to provide an opinion on global warming because there's some controversy, as some people say that it arises naturally and not due to man-made effects. And I'd also like you to explain the mechanism of tidal locking in your own words. And also, do you think that the moon landings were a hoax? If not, provide strong reasons to support your answers. And let us know your ideas as to how do you think Mars can be transformed into a viable human base, and do you think that the moon is a better option? Also, what do you think that after Chandrayaan and Mangalyaan, what should India's next planetary science objective be? So we look forward to hearing from you on the group, and that's all for this time.